So, good evening. Welcome to the Handley Page Lecture for 2021, co-sponsored by Cranfield College of Aeronautics Alumni Association and the Royal Aeronautical Society. My name is Dougie Hunter and I'm chair of the Cranfield College of Aeronautics Alumni Association. A little bit of housekeeping to start with. There are quite a large number of people who are joining us through the medium of Zoom. Can I please ask that everyone who's joining us from Zoom keep their microphones muted while the lecture is in place. That will avoid any echoes or spurious feedback. Those of you who know Zoom will also recognize that there is a record function on the medium of Zoom. Can I please ask that you do not press the record function? This lecture is being recorded and will be made available in a few days' time. You will all receive an email giving you the link to the recording at that point in time. I am a Cranfield College of Aeronautics alumnus from 1985, and I've held a number of engineering and business management roles with BAE Systems, Airbus, Aircraft Research Association, Marshall Aerospace and Defence, and the Manufacturing Technology Centre here in the UK. And I was also a member of the Cranfield University Management Council from 2011 to 2018. The Handley Page Lecture is dedicated to the Handley Page Company and Sir Frederick Handley Page. Sir Frederick was a member of the 1943 Fedden Committee and was instrumental in establishing the Cranfield College of Aeronautics in 1946. He subsequently served on the College Council and was a past president of the Royal Aeronautical Society. Sir Frederick passed away in 1962, but Cranfield and the Royal Aeronautical Society wished to honour his memory by creating the Handley Page Lecture. The first of which was delivered by His Royal Highness the Duke of Edinburgh on the 21st of May 1963, with the title Education for Technology. As many of you know, the college has used Handley Page originated jetstream aircraft for many years, with the first being bought unfinished in 1969. The last flying classrooms have recently been replaced by Saab 340, and we heard a bit about that at last year's lecture. I would now like to introduce you to our speaker for the evening, Professor Fernando Alonso. I hate to think about it, but I've known and worked with Fernando for the best part of 30 years. Fernando is an aeronautical engineering graduate from Madrid Polytechnic University and a flight test engineering graduate from École de Personnel Navigant d'Essai et Réception, the French test pilot school. With over 4,000 flight test hours of experience, Fernando was also the lead flight test engineer for the Airbus A340-200, A319, A318, A380, and A350 aircraft. From 2002 to 2007, he was vice president and head of the Airbus Flight Test Centre in Toulouse. He was then promoted to senior vice president, head of Airbus Flight Operations, responsible for over 1,500 staff located in Europe, China, and the USA. In 2015, Fernando became the CEO of Airbus Military Aircraft, president of Airbus Spain, and a member of the Airbus Group Executive Committee until his retirement from Airbus in 2019. In that same year, 2015, he was awarded the French Chevalier de Légion d'Honneur. My French is not very good at these days. It's a little while since I've been there. I know he keeps himself busy with a number of roles that he has acquired since his retirement from Airbus, not least of which is his involvement with Un Sourire d'Enfant, a French NGO working in Phnom Penh in Cambodia to provide education, healthcare, vocational training, and higher education to underprivileged children. This evening, Fernando is going to lecture to us on the flight test campaign of an aircraft that is fairly close to my heart, the A350, and the new ways that we use to deliver the campaign. Please welcome Fernando Alonso.
Well, thank you, Dougie. Thank you, Cranfield. Thank you, the Royal Aeronautical Society. for giving me the opportunity to speak at this lecture today here in Cranfield. And let me tell you, from a personal point of view, I am discovering new grounds. This is the first time I'm doing a lecture. I've done in the past lectures virtually, where I'm speaking to my screen. Today, I'm delighted to be speaking to the audience here, but I discovered the wonders of talking to the audience. I'm talking to another virtual audience on the other side of the screen. So thanks for letting me have this new experience, gentlemen. Yeah, thanks, Dougie, also for your words, very kind words. Yeah, we have known each other for many, many years. Both of us were almost in shorts at the time, but we have lived through a fascinating period in aeronautics. And I was reflecting yesterday as I was coming here. You know, we have most of us here in this room, at least the more senior ones. We have lived through a fascinating period of aeronautics. I remember when we started, you know, airplanes had dials, and airplanes had 3 crew members. And then we went through what we thought was revolution, you know, digital screens, digital fly-by-wire systems, long-range, high-precision navigation, GPS, and all those things. You know, they have really changed the way we fly today. But I think the students that you guys are learning and that are in the university today, they are in front of a much, much bigger revolution that we have ever seen ourselves. So, you know, I really, you students here, or you students who are listening to me, realize how privileged you are to be able to contribute to this fantastic industry of ours, which is aviation, in such a unique way that, you know, I think, you know, none of us have ever lived before. So we have a big responsibility to take aviation from where it is today to where we expect it to be in 20 or 30 years from now. So that was my reflection of coming over yesterday, and it just put things into perspective. You thought you had done great things, and we did great things, but the challenges that young people, young graduates have today are absolutely phenomenal. But I'm sure they're getting excellent training here and in other such institutions. So I wanted to share with you today something which, at the pace the world is going, may seem old, but it only happened 4 or 5 years ago. And this was, I want to share with you sort of the insights of what went on behind the scenes during the A350 program, and specifically during the A350 testing activity. So I'll start with a film, short film, which shows some of the highlights of the A350 flight test campaigns. Those are probably images that you have seen previously, but just to remind us what flight testing is all about. I will then go into behind the scenes, what is not told in the video. So it did work before. It should work now. About this. There you go. Oh. Okay. So, as I said, that was those are quite, I would say, conventional videos, which you usually see in every development campaign or flight test campaign of a new airplane. But I really am more interested today in explaining to you what had fundamentally changed in the background to make all that happen. The fact of the matter is that every flight test campaign, there's for every new development, be it an airplane, be it a helicopter, be it whatever, there's a universal aspiration that we want to reduce the development cycles. Why? Because the customers are expecting product early, because there's financial pressure, because the sooner you deliver, the sooner you start earning your money, you stop investing in the development. And yet development cycles of airplanes, it seems to be very difficult to reduce. And being at the end of the chain, the flight test activities, at the end, you tend to have the pressure on the flight test campaign. So how can you do to reduce the flight test campaign? Well, it's not straightforward. And we decided that we had to do something differently in Airbus. So the fact of the matter is that when you saw how long it took to flight test brand new models, starting with the A320 back in 1987, that airplane was certified barely 12 months after its first flight. A330, A340 was more like 14, 15 months. A380 was close to 20 months, if not more. And, I was always asking myself the question, well, how can it be that, we have more and more sophisticated data analysis equipment, we have more and more sophisticated instrumentation, we have more powerful tools, we have simulation capabilities, yet we do not seem to be able, with all those means and processes, able to compensate the added complexity of the airplanes, the more strict requirements from a certification point of view, the higher expectations of the customers, both in terms of reliability, operational reliability, maturity of the airplane, the bigger expectations from the passengers in terms of in-flight entertainment system, quality of the airplane, better passenger experience. So on the one hand, there was a balance. There was more expectations on the airplane. We had more powerful tools. We had more means of doing it. And yet the net result was that things were getting longer and longer. So unless we changed something, we knew the result that was going to be on the A350. So at Airbus, we decided to tackle this problem quickly. And this is just a slide which, when you will be reading it, you'll see that it just lists the number of parameters that were recorded on those airplanes, just to illustrate the progress that we did. A320 had about 12,000 parameters. The A350 had 670,000 parameters recorded on instrumentation. So it's the investment and the quality of the tools that we had was absolutely enormous, yet the net result, as I said, was negative. So what we decided to do, of course, and I will be talking today about us flight tests or ground tests or whatever, and let me reassure you, it was not just about us. It was the whole company, the whole program, the way the program was organized contributed to this. But we, in the testing area, we contributed by doing this. So what we saw is that in the past, in Airbus, we had an organization where each discipline or each engineering organization was responsible for the definition, the design, and the testing of their individual system. There was an organization which was responsible for integrating all the systems. And as the flight test organization, we were just invited or were participating right at the very end of that integration process. And frequently, I had been very vocal with my management to say, well, so many times we fly and we discover anomalies or we discover behaviors of the airplane or its systems. Did you know about them? And you know what? Many of the times the answer was yes, we knew about them. And well, how come we didn't know? So there was clearly a disconnect between the testing organizations of the individual organizations and us flight tests, which were at the end being faced with the program. So after we decided jointly in Airbus that we had to do something. And since I had been so vocal about it, I said, well, go ahead and do it. And so that was a big challenge, but I had very clear in my mind what needed to be done. And what needed to be done is bring all those testing people together to ensure a continuous testing from cradle to grave. So the same people who would be involved in the testing of the airplane at the end, those people were involved in testing the equipment, the systems, right at the very beginning. So we decided to create what we called a flight and integration test center. And I've illustrated this by a slide which shows that on top we had the airplanes and below we had all the test rigs. But I'll go more into detail of what it actually means. We gave ourselves 3 objectives, very simple objectives. Of course, ensure the safety of flight. When you're flying the airplane, that's the first thing. You need to ensure the safety of the flight test and of the crews. But 2 objectives that we had to certify the airplane was obvious, so it wasn't even an objective. But we said we want to develop this airplane to drive the product maturity and to reduce the development cycle. Why drive? Oh, I'm painting. Why drive product maturity? Because again, our customers were expecting an airplane that would be mature as soon as it entered into service. It wasn't the case in the past. And the airplanes suffered from malfunctions, failures, difficulties in the operation of the airplane, difficulties in the maintenance of the airplane. And we discovered that late. And of course, the customers were suffering from that. So one of the big challenges on top of reducing the cycle, we said we will reduce the cycle of the development of the airplane, but we will also improve the maturity of the airplane and its systems when it goes into service. And we gave ourselves the company gave themselves very strict requirements in that we committed to our customers to achieving, I think we'll see them in the end, the numbers, something like 98% operational reliability or entry into service, and something like 99.5 operational reliability 1 year after entry into service, which was never known in the past. So it was a huge challenge, but we enjoyed that challenge, and we figured, let's see if we can do things differently in order to achieve that objective. And of course, the result, what we were expecting, and we tried to quantify it, we said we will reduce the development cycle of the A350 from what would have been maybe 24, 26 months. We'll bring it back to something comparable with what we managed to do back in the 1980s, which was the A320. We committed to 14 months. So that was the challenge. Here we had a new product, which everything was new about it. We had given ourselves a new organization, a new ways of working, and we had a very clear objective of what we wanted to do. We wanted to develop this airplane, certify this airplane in 14 months, and wanted to achieve an operational reliability of 98.5 at entry into service. So off we went to do it. And we put our focus, first of all, on the people. As I said, it was all about extracting from the different testing organizations that were spread throughout the different design teams, extracting those teams and extracting those systems, those test benches and others from the design organization and putting them together in a testing organization, so that the same team would be involved in the design of the airplane, in the testing of the airplane from cradle to grave. And here, to illustrate that, I've listed 4 or 5 different types of people, different types of staff of this new organization, where they would be involved. So people who were defining testing strategies, so what type of test means do we want? What type of instrumentation do we need? What type of simulators do we need? They were involved in the development of the A350 from day 0, from the time that we were deciding, what type of airplane do we want, what type of. The flight test crews, the pilots, the flight test engineers, they would be involved right from the very beginning, to help the design teams assess the handling qualities, the systems definition, the cockpit interfaces, all of that. The test means people, the people who were designing and operating the test means, again, they were involved from the very concept phases in order to ensure that the airplane and its system were designed for testability and for maintainability. Because otherwise, we wanted to avoid that you design wonderful systems but very difficult to test, very difficult to maintain. So we integrated those operational concerns right from the very beginning. Same thing with instrumentation. We discovered that each team previously was using different instrumentation. So the measurement that we were seeing on one test rig was not necessarily, we did not know how to correlate it with what we were measuring on the airplane. So we ensured that every one of our test means was using the same instrumentation with the same characteristics, with the sensors positioned in the same positions. So we would have a continuity of testing. So at the end, it was all about that. We wanted to have a continuity in all the testing activities that we would be doing from this airplane, from the very early stages of the design until the very end of the certification and after entry into service. And it was more than anything else, I would not say a cultural revolution, but it was a little bit like that. Why? Because we had to position this new team as the challengers of the designers. And of course, in an organization, it's difficult to say, well, why are you going to be challenging me? Are you going to be criticizing me? Do you really mean that? Why? So it was about to say, it was all about making people understand in the organizations, not just flight tests, but throughout the organizations, that our job was to look at the product from a different angle to the people who had designed it. And the people who had designed it, they designed it with looking at it from one angle. We were going to be looking at it from the other angle, and that was the angle of the operator. You know, at the end, we're building an airplane, not for us, but also for our customers. So we wanted to introduce this concept of we are the first customer of the airplane. So the sooner we find things that we're not comfortable with, or the sooner we find things that do not work, the sooner we identify them as like a customer would do it, the sooner we can fix them so that the customer will never have to face those difficulties. So it was this change of culture, different way of working, and early involvement of the test teams very, very early in the program so that they would get familiar with the behavior of the systems and the equipment. And I've put in this line something to illustrate that involvement. So in the previous slide, you saw the involvement from cradle to grave. And in this one, it shows the involvement of the teams throughout the testing area. So you start with supplier testing components. So we had our teams being at the supplier site, actually witnesses or participating at the test that the suppliers were testing their components. Those components would then be brought in-house, and we would have test rigs internally, which we call SI-based system integration benches or function integration benches, FIBs. System integration bench is a bench which just uses one system, just looks at one system, the components of one system. But of course, these airplanes are extremely integrated, and all systems talk to all systems. So we found the need of building what we called a functional integration bench, which combined 2 or 3 or 4 different systems, but all working together in an integrated manner, like they do work in the airplane. So we added that intermediate functional integration benches for the first time on the A350 in order to be able to look at the interfaces of various systems that are actually working with each other. We had an Ironbird, which, as you probably know, is an airplane sitting on the ground with all the hardware representing the actual aircraft, be it hydraulic system, electrical systems, landing gear, all the systems actually working together. And of course, that Ironbird could be flown through the simulator. So we had simulators that were standalone, but you could actually fly the Ironbird from the simulators, and that we used to call aircraft zero. And we also developed very, very powerful and big test rigs. We developed a landing gear zero rig, which was in Filton, where it was literally a complete landing gear system, braking system, doors, which was able to operate, and we were able to do a lot of development testing on the test rigs themselves. We had a landing gear zero, a cabin zero, which was a complete cabin of the airplane with all the passenger seats, galleys, toilets, passenger entertainment system, in order to develop and get knowledge of the cabin environment. We had a flight test bed. It was the first. It was a new engine that was built for the A350 Trent XWB. So we had one of the airplanes, one of our A380s fitted with one of these engines, and we actually did a flight test bed campaign on it. And we had a big fuel rig also in Filton, a big facility where we were able to actually have the complete fuel system of the airplane, with the capacity to demonstrate or test refueling, fuel feeding, fuel venting, fuel transfer, with the capability of making pitch move, actually moving the test rig itself. Very, very powerful tool. Also, the Filton fuel test facility had the capability of heating fuel and cooling fuel. You probably are aware that there have been a number of accidents on other airplanes because of ice crystals on the fuel. So we were able to explore those type of behaviors because of this heating facility that we had in our test rig, and which we later during the test campaign actually used to feed into the airplane and do the hot fuel tests in an airbase in the south of UK, Cornwall, Kemble. So we actually brought the airplane there, and with special insulated trucks, we heated the fuel in Filton and transported it to Kemble or whatever it's called, and actually did this. So in the past, we had to go to Eastro, we had to go to Saudi Arabia, and here we could do it in the UK, heating fuel in the UK. So all those ground test means were designed, operated by the same test team. So that was the beauty of it. So our pilots, when they would fly the airplane, odds are that they have already been involved in doing the systems testing or the function testing. They have definitely been involved in simulator tests. So it was a wealth of knowledge that our pilots, but also our ground engineers who were doing the data analysis or doing the development of the systems. It was a wealth of knowledge that was previously siloed, and now all of a sudden it was transparent. So we thought it had a great potential about it. Something that we did also new was we did what we call a virtual flight campaign. So we used all our test rigs, mainly the big ones, to do a virtual test campaign. So we'd actually operate the rigs in an operational environment in order to start debugging. How is the operation of the airplane? How's the operation of the rig using normal operational environment? In that virtual flight campaign, we included a virtual first flight with passengers. So we actually had, I don't remember how many, but maybe it was 200 passengers. We put them into the cabin 0, and we put them there for 5 hours. And we fed them, we showed them videos, and it was all about understanding how the system was behaving, how the air conditioning was circulating, the lighting was working, the passenger entertainment system was working. And of course, because you're on the ground, there's so many things that you could be doing real time. You could be tweaking different things, the lighting, whatever. And so we actually, we had volunteers, company staff who actually participated to that. So the whole of that was try to test upstream as much as possible. Try to learn as much as you can about the airplane and its system as much as possible. The sooner you test, the better it's going to be. So by the time we got to the first flight, I think we were in a really good condition. And here I've put some pictures of the most impressive. I was always really impressed by these big, huge rigs. This is the flap and slat rig, high lift rig, which is sitting in Bremen. And the flap system of the A350 is very sophisticated. It does not just do high lift to increase the lift of the airplane. It does flap cruise control. So the camber of the wing changes in cruise depending on the CL of the airplane. It is used to laterally trim the airplane. There's differential flap settings to improve the takeoff configurations and the landing drag. So it does a lot more than just purely high lift configurations like we know them in conventional airplanes. So we had this fantastic facility in Bremen, and they were able to experiment with that, and we did learn a lot from the operation of the flap system. It was the first time we developed something like that. So we knew what we wanted it to do. We're not sure how to do it. So this was really very helpful in developing and troubleshooting and fixing issues on the high lift system before we actually flew the airplane. Cabin zero, I just talked about. These are the passengers boarding for the trip to nowhere, 4-hour trip to nowhere in Hamburg. And this is just to give you an order of magnitude of the amount of testing. Roughly speaking, I don't remember the dates. I could find them, but I don't remember them. But roughly speaking, all these big test rigs were available about a year before the airplane flew. So there was a big effort. Again, it was all about anticipation. So, the sooner we get them, the better. However, they cannot be just in any configuration. So it was all about, and that the program, the A350 program, did a tremendous job about synchronizing the availability of the test rigs and the availability of the equipment to install those test rigs. Because if you have the rig, but you don't have the equipment, you have done nothing. So it was all about, coordinating and making sure that you have the rigs at the right time with the equipment to feed them. And as you see there, these are the hours that we did on those rigs before the first flight. So over 4,000 hours on the Ironbird and on the high lift system, close to 3,500 hours on the landing gear rig in Filton. Simulators, we had 2 simulators, 4,700 hours. So as you see, a massive amount of testing. Fuel rigs, 670 hours of testing, cabin 1,500 hours. So it was all about not just testing continuity, but test as early as possible. Try to advance as much testing as you can. Don't wait until you fly to test. If you can only test, there's things that you can only test in flight, so that be it, so be it. But anything that can be tested on the ground, let's test it on the ground, and just learn from that. So that was the focus of the new test organization. The flight test program of the A350 was, in a way, quite conventional. We had 5 test airplanes involved in the development. The first 2 airplanes were very heavily instrumented. We had 2 airplanes with a cabin interior, just to illustrate the importance on big commercial airplanes of the cabin. No-go items are flight controls, computers, but no-go items are also toilets, or no-go items are also in-flight entertainment systems. So you could have an airplane not being dispatched because some toilets don't work. You can't have an airplane not dispatched because the in-flight entertainment system does not work. So, it's the frontier between what is critical and what is not critical is blurred in the commercial world. So that is why we have 2 airplanes with a complete cabin. And 2 airplanes with heavy instrumentation and 1 with light instrumentation, mainly devoted to avionics and autopilot development. The total was supposed to last 14 months, and we were supposed to fly 2,500 hours. Do we have the time? How are we doing time-wise? It's okay. So let me show you a little video of the first flight of the A350, which is very emotional. You've probably seen me. I look much younger than I am now, but that was many years ago. The first flight is always a very emotional moment. It's an important moment in the life of a corporation, big like Airbus, because that's the time with and you have to make the best use of it. It's a time when all the people have been working hours and hours and weeks and days and months and years. They have been working on the product and giving the best of themselves. And this is the first time they see it happen. So it's a very powerful moment to get the teams aligned, to get the teams motivated, to get them all pushing in the same direction. So if it's well used, it's a very, very powerful moment. And we try to make the best use of it. And I have to tell you that I'm generally an optimist, but I wanted to convince myself that we were on the right track. But I have to tell you, I've done a number of first flights, like Dougie mentioned, and I really had great feelings after the first flight. I would lie to you if I would tell you that everything worked. Everything did not work. We had lots of limitations. We had a lot of deficiencies. We had a lot of malfunctions, but most of them we expected. And that it makes a hell of a difference. When you know something may happen, when it happens, it makes it much easier rather than having to think, what's this about? Do I know about it? And just from the very first flight, we had a great feeling of comfort and a great feeling of, hey, it looks like we're really on the good track. So to the point that we were so confident on it that not less than a week later, I don't know, remember it was flight number 2 or flight number 3, we actually overflew Le Bourget. Because we were just so comfortable with the airplane. We didn't do a flight display, but we just overflew Le Bourget. So we were just so comfortable with the airplane. And then we overflew Le Bourget, which was much appreciated. So just from the beginning, we had a good feeling of, it looked like we're getting somewhere. I would just want to highlight a couple of things that we did differently that we had done in other campaigns. We wanted to do climatic tests, and climatic tests are always very time consuming because you have to go to different places in the world, and they're far away and big logistics. Always when you get there, the weather's not right. You have to wait for an extra day or an extra 2 days. And it's very unpredictable. And of course, in the tight campaign that we wanted to run, we could not really afford to say, okay, I'm going to Northern Canada and I have 4 days of testing. So how many do I need to plan? Do I need to plan a week? Do I need to plan 2 weeks? Because once you're there, you're gonna do it. So we could not afford to bring that uncertainty onto the program. And we found we found it had been existing for many, many years. We just didn't know about it. This great facility in the US called McKinley Climatic Laboratory, and where we could actually fit an A350 inside. And they have the capability of heating the airplane or cooling and create an environment. And as you see there, we tested there, hot and humid, 32 degrees and 90% humidity, typically Southeast Asia, Hong Kong, Singapore. Hot and dry, 45 degrees and 15% humidity, typically Middle East, Emirates, Saudi. Cold, minus 30 and minus 40 degree, typically tests that we used to do either in Siberia or in Northern Canada. So it was a very, very efficient. We went there, we had planned there to be for a week, and we were there for a week. Airplane left and a week back, a week later, it was back in Toulouse. That is extremely valuable in controlling your campaign. The one thing that we had not thought about is that, of course, engineers are engineers. They want perfection all the time, and it's great. However, when you were doing climatic tests in the outside, well, the temperature is not always at 35 stable, and it's not at 40 stable. Or if it is stable, it does not last forever. But here, we had a toy where actually we could put the airplane at minus 40 and just leave it there. Or we could put it at 35 and just leave it there. And so the role of the guys who were there, they called and they say, hey, what do we do? And say, well, you know what you need to do. Once you've done it, don't do more. Once you get your data, come back, because the engineers wanted to get more. So, and it was tricky, and it was difficult for us to explain to them, but I eventually understood. But they had a wonderful toy in a laboratory where you could say, I want minus 40, and I'm going to wait until every single part of the airplane is at minus 40. Because the regulation is saying 12 hours cold soak at minus 40, at 12 hours and 1 minute, end of the test. Don't wait until, I don't know what part of the airplane is it not yet at -40? I don't care. What does the regulation say? Of course, the regulation says -40 at 12 hours. You know, it's a long time with the doors open and everything open. So that was a challenge that I was not expecting. But again, overall, I think it was a fantastic campaign. And as I said, it helped us do the job and contain the risk on duration of that campaign. I think you saw images already in the initial shot. It just shows the airplane. I have to say in that facility, you're able to operate the engine, so you can start the engines and run them at idle, which is also part of the game. You know, when it's in hot or when it's in cold, you know, starting of the engine, oil leaks, fuel leaks, things like that is important. So it is important to pressurize all the systems. So it was. This is another new test equipment that our Cabin Zero team invented. Because of the importance of the air distribution and comfort in the cabin, they designed these dummies. Those are passengers, but those are really disciplined passengers. You can actually heat them, cool them at wish. So in fact, they're just a very simple tube with water and a resistance inside. So you know how many calories a human being develops when he's eating, when he's sleeping, when he's not, and all of that. So we could at will, just change the conditions of the airplane and be able to test again in a controlled way, but in knowing the time it's going to take. We could test so many different configurations without necessarily having to have the passengers and having to stabilize the passengers and all that. So this was a very, very effective way of tool that we developed in order to test. What did we test there? Typically, it was air conditioning, ventilation. You know, the air conditioning and the ventilation, the airflows. Make sure that you have no drafts, and that is critical for the passenger comfort. So that was extremely, and that was typically a result of this working together. The design, the engineers, the testing engineers on the cabin, they said, we have this idea. What do you think about it? And we didn't have to talk to many people who said, let's do it. So it was that was also an important element of novelty. We did early long flights with passengers. These are employees again to validate what we had tested by ourselves in the airplane, but with passengers. And we ended up doing a route proving campaign, a functioning and reliability campaign, where we operated one single airplane for 20 days. We did 26 flights. We did 180 hours nonstop. And the purpose of this was to demonstrate there's a requirement called functioning and reliability, which I'm not sure that you're familiar with. That requirement requires that when you have a new airplane with a new power plant and it's a new design, you need to demonstrate 300 hours of normal operational flying to demonstrate that all the systems work. This requirement comes back from the early days of the 747, where with the Pratt & Whitney JT9D, I think it was, where at the very early stages, there were a lot of engine failures. So in fact, it ended up that the 747 was having many times to operate in a 3-engine configuration. Not an issue. The airplane flies beautifully with a 3-engine configuration. However, the probability of failure that had been accounted for in the safety assessments for the complete airplane was a little bit biased, because the probability of failure was not 10 to the -5 or 10 to the -4, it was maybe like 10 to the -2. So that's where the authorities said, the FAA said, and then it has become accepted by everybody, you will demonstrate that an airplane can fly for 300 hours in a normal operation with reasonable number of failures. So it's not supposed to have no failures, but at least they were expecting to identify some new type of failures or young child illnesses of the airplane. So we did that, and in the process of doing that, we also got data to certify the airplane for ETOPS for 360 minutes or 6 hours ETOPS from day one. Again, I think that was definitely supported by the good level of maturity that we are seeing on the airplane and its systems. So that is for the flight test campaign. I also now want to focus on something which we did different, which was for me was fundamental. And that was, remember at the beginning, I said the objective of this new organization was to reduce the development cycle, but I said also to improve the maturity of the airplane. So we believed that during the flight test, there's a lot of data that we could use and was not being used about the operation of the airplane. So what we said is we will operate our airplane as if we were an airline. So the flight organization was the first customer of the airplane. We called ourselves Airline One. And we will operate, maintain, make modifications of this airplane as if we were an airline, with the same type of organization as an airline. Of course, we needed to protect the fact that we were doing flight tests, so the priority was flight test. So in a nutshell, it wasn't exactly like that, but more or less it was, okay, we have to do a work on the airplane, go ahead and do it, apply the normal airline procedures, the maintenance manual, the troubleshooting guide, whatever, apply it, try to fix the airplane, or try to configure the airplane. If you don't manage at takeoff time minus TBD hours, say 2 hours, 3 hours, end of the game, now you go into commando mode and then get the airplane ready to fly. So we try to mix those two things. So what can we learn about how to operate this airplane and to maintain this airplane whilst respecting the objective of doing the test that we have to do. So we called ourselves, we organized a structure we called Airline One. And the purpose, as I say, was to operate, maintain, and work on the airplane using the same procedures, the same manuals, the same processes as an airline would use, and use the findings that we would have doing that. A lot of things would not work. The manuals were not clear. The e-logbooks were not working. All that kind of stuff. But because we were exercising it from day one, we found anomalies. We were able to capture them and try to correct them as soon as possible before entering into service. And so this is how it was organized. We called Airline One. It had a flight operations department who had an operations control center, an e-operations. That was the department that was responsible for generating our flight plans, generating our operational documentation, NOTAMs, you name it, flight planning, all that. And we had an engineering organization, one which was responsible for maintenance, which included production planning and maintenance control center. So the people who would plan what would be the modifications planned of the airplane, what was the maintenance activities planned for the airplane, to which we had to add malfunctions, failures that happened during flight test. And then the maintenance control center would actually integrate both the routine maintenance activities and the results of the flight tests into a working plan for taking care of the airplane. We had our own facilities. We had flight line and line maintenance facilities. We had our own hangar to make modifications on the airplane. This airplane is carbon fiber. So whenever you have to do any modifications on the structure, you need curing times or you need temperatures. So we had that. And we had an operations center, which was using, again, the same tools, the same applications that the flight operations organizations of the airlines would be using. And another cultural revolution was we said, well, we are going to be operating as an airline, but do we really know how to operate as an airline? And of course, customer services guy says, yes, we know what the airlines do. We're just fine. So come and join us. But I was uncomfortable and I said, well, the ones who know how to operate are the real airlines. So I want the airline people to be with us. So the flight operations people, maintenance people, engineering people. And of course, again, the initial reaction is, wow, you're not going to have a customer here with you. You're not going to have them witnessing everything you do. But, with explanation, it was in our interest to have them with us. It was in our interest to have them help us diagnose, help us troubleshoot. Actually, to the engineering team, help us to prioritize. When you have an anomaly, it was great to have these guys with us to say, well, if I were you, I'd better put priority on this because that is more penalizing for us when we operate than that one. So in a lot of cases, we got a fantastic help from the airlines. There were not many of them. There was about 10 or 15 or some coming from different backgrounds. We had Qatar Airways, we had Finnair, we had Fnor, we had US Airways, Delta now. So, and they were actually integrated with us from day one. So it was, airline office was part of Airline One operation. And I have to say, we're very proud of the work they did with us. And as I said, they helped everybody. They helped the customer services team in making sure that the manuals, the logbooks, the iPads and all that stuff, but also engineering teams, the design teams, prioritizing what fixes would be needed and when. Very, very powerful. And these are that is the airline team. So the guy on the left is the project pilot of Delta, who was with us all the time. He was with us. He spent a year with us, flying the airplane. He would fly with us, and to the right was Peter Chandler, and he'd be flying with us. And that's him below in the flight test engineer station. So he was literally part of the team. And that again, of course, when you come towards the end, it's all about how can you quantify? Was that really worth it, or was it not worth it? So the first area where we started to see that it was really worthwhile, other than our gut feeling that the first flight went really well, when we were tracking the number of snags that we found during the flight test activity, we saw from the very beginning that the number of snags that we're getting on the A350, which is the blue line, was significantly lower than the number of snags that we had generated on the A380 per flight hour. So the A380 was the red line, the A350 is the blue line. So you see roughly and quite consistently throughout the campaign, we generated half the snags that we had generated on the A380. I'm sure you can imagine the value of that. All those snags are items that don't need to be analyzed, and they don't need to be investigated because they're not there. Probably they happened before. Probably those snags we saw previously on the simulator, on the rigs, or on the supplier testing. I'm not saying that the A350 was so much better than the A380. I'm just saying, if you accept the fact that there will always be anomalies, for me, the difference between those two lines shows that probably all those things happened. They happened before. We captured them before, and therefore they did not happen later. So for me, that started giving us a flavor of what of what we were getting out of that. So very positive results of that. And then I want to show you also something which was a little bit crazy, but it actually worked. And that is, as part of our role in Airline One, we said, we want to monitor the operational reliability of the airplane, how we want to measure it ourselves and extrapolate it to what it will be in airline operation, knowing that our operation was not 100% airline operation. Air was not represented because of our environment. But we said, let's track what would be the operational reliability and try to extrapolate what it will be when it enters into service. And we started tracking things like operational reliability. We started tracking the contribution to the operational reliability. That's the bottom left hand of the individual 88 chapters. We were measuring the numbers of removals, and the chart on the left is the operational reliability as we were measuring it ourselves. So we saw that it had very big fluctuations, but with time we got really good at it, and the people really started feeling that there was some benefit to get out of it. And this is how it looked at the end with the A350-1000. On the bottom line, you see the operational reliability as what expected based on the flight test data. That was extrapolated to the blue line, which was supposed to be the operational reliability as would be seen by the airline. And in fact, at the end, it worked quite well. We were able to identify the contribution of different modifications to the improvement of the operational reliability. So on the right-hand side, you see chunks of data, green and number and so those were modifications that when they would be brought into operation, they would contribute so much improvement in operational reliability. And the actual numbers that we produced at the end, at entry into service, we had committed to our customers to have 98.5 operational reliability. Well, we missed it. We only had 97.2, which is not bad. 1 year after, we were supposed to have 99%, but we missed it also. We were only at 98.3. But 2 years later, we were supposed to be at 99.3, 99. So we actually missed our target by 1 year. However, I think what we saw is that in other projects, we started from a different level. The customers might not be happy, but then it took us forever to converge. Here, we converged within 2 years. Why did we converge within 2 years? Because a lot of the modifications that would contribute to that improvement in operational reliability were already in the pipeline. So they were already being designed, they were already being developed. So we were able to introduce them into service much quicker. So for me, that was a clear proof that the work that had been done previously in way of handling the airplane during the flight test was very, very valuable. And I have to say that I think this process that we changed on the A350 remains active in Airbus. I think we opened the way of a new way of testing in Airbus, which not only focused in testing for certification and testing for development, but it evolved in testing, bearing into account the end user, testing, having in mind always the operator that would be operating the airplane. So I want to finish with a short, so this is the number. So we had committed to 2,500 hours in 14 months. We didn't make it. We exceeded by 50 hours and 2 weeks, but we were quite proud of it despite all that. There's us with the type certificate of the airplane. And I want to show you a very pretty video of a formation flight that we did on the day of the certification. We had 5 airplanes. We were so proud, so happy. And we said, let's all fly together. And we got all 5 airplanes flying on a formation flight that was very beautiful. So that's it. I think this A350 campaign was a big honor for myself and the whole team participated in it. I think we demonstrated that we were able to break this trend that seemed impossible, and it was difficult to understand why it was impossible. And I think that with the A350 campaign, we demonstrated not only with testing, but with the whole company aligned with that, by ensuring a continuity in the testing teams, ensuring that the guys who will be testing the airplane will always do that, installing a spirit of challenging the design teams, bearing in mind the operational considerations, involving the customer in the development campaign from the very beginning, always operating the airplane, bearing in mind always the end user. I think in the end it paid off, and I'm very happy to see that Airbus continues working along those lines, and I see no reason why it should change. But I think it was a very exciting exercise, very exciting campaign, and it also gives me a lot of hope that even big organizations like Airbus, they can change and organizations change. If you have good ideas, you have good leadership, the company is aligned, you can change ways of working very, very significantly. With big organizations, there should be no fear of that. If you are determined, you know what you want to do, you understand that, you have good leaders, you can change even big organizations like Airbus. So I thank you very much again for this experience of hybrid conferences, and thank you very much. And I don't know about questions and answers. I don't know if there's any questions.
Thank you for that. We're a little bit over time, but
I'm sorry about that.
No, I could have listened to it.
I get excited.
Another hour. Maybe we take a couple of questions. So, Jack, do we have? I'll take one or two from the floor and one or two from online. Do you have one from online?
Yeah, I've got a question here about the lessons that were able to be learned from the Dash 900 flight test campaign and then applied to the Dash 1000 campaign. What time savings were made?
No, in fact, I think, yes, the lessons learned during the A380, the Dash 900 campaign were right across to the A3 to Dash 1000. And in fact, I saw at the end, I showed you the traces of the A3 of the Dash 1000 in terms of operational reliability. We had already planned the Dash 1000, assuming that it all worked. So when we planned the Dash 900 and the Dash 1000, we planned it on the same assumptions. So we assumed it would work on the Dash 900. It did. So those assumptions remain valid on the Dash 1000. So yeah, I can see the bosses coming and saying, okay, so now you'll do it shorter, which will happen, and it's natural. And that's a great challenge for the testing.
Is there a question from the room? Maybe hold 1 second.
First of all, thank you for the presentation. It was quite insightful. This sort of a quick, let's call it quick test campaign certification, right? An aircraft is not designed to be, or at least certification process is not designed to have this, to bring this quick a product of the market. Did you find any feedback from the certification agency? Did they get something back from you as to speed up the process or to change the process somehow?
Yeah, the certification authority, they don't have a time dimension like us, the manufacturer has a time dimension. However, my recommendation is always involve them as soon as possible. Collaborate with them. The sooner you involve them, the better it is. The more they will know the product, and the more they will be familiar, and the more they will steer their investigations to areas which are important. So I would say the authorities, they will not drive you to reduce your testing campaign, but if you manage them correctly, they will support you doing those objectives. So we had great support from the EASA. They were, we said, we're going to be flying at these rates. We need your availability in these times, where they were able to provide the crews to operate. We would operate them, but we had agreed on protocols. So what if you're not available? So we identified what tests we could do without them that they would want to witness, but what tests, if they didn't, if we're not there, we could still go ahead and do them. So it was a very transparent and open discussion with them in order to make sure that they would not be the limiting factor of the campaign.
Jack, is there any more on that?
Yeah, there's an interesting question about aircraft modifications and how they might be flight tested. Things like the addition of rear fuel tanks for very specific operator requirements.
What was the question exactly?
It was about the Dash 1000 requiring an additional rear fuel tank for a very specific airline. I won't mention the airline and the program, but how does that incorporate into your
I don't know the details of that one, but I mean, we have added additional fuel tanks on different airplanes. We add them on different airplanes, and at the end of the day, yes, you need some integration testing, because that additional fuel tank is going to be refueled how, it's going to be venting how, it's going to feed onto what, is it going to feed onto the the feed tanks, or is it going to be feeding to the center tanks or whatever? So all that I'm sure must have been, I mean, it usually tested on the ground, and then you verify in flight. So yes, there will be a certification program covering the integration of that new system, both in all systems which would be impacted. So it's not just the fuel system, it's the level sensing for the fuel gauging. It'll be the instrument for the displays on the cockpit. It is the definition of the procedures in case of failure. So any modification that goes into an airplane needs to be certified whenever it comes in. If it comes in at the type certification date, it is done piggybacked with the rest of the airplane. If it comes later, you make a specific campaign for that.
Question from you?
So thanks for the amazing presentation. You mentioned that the whole test campaign was changed thoroughly. So my question is, how long did the planning phase take to draft the new SOPs for such a big change in the testing campaign?
How long does it take to host time?
Like you mentioned, usually there is a particular set of personnel that was involved in testing phase A, and it was different as the testing phases went along. But in this case, you had the same people working throughout the test campaign, and even the operating procedures, like having the sensors in the same place, and then the time that takes to recalibrate them, you avoided them by having them in the same place. So this calls for a change in the SOP. So,
well, you know, yes, we were asking teams to enlarge their level of competence and to enlarge their level of visibility, because, you know, we would say teams, you know, you're involved in flight tests, but now you're going to be going to see your suppliers, or you're going to be involved in flight tests. We were telling, you know, pilots, you're going to go and see a supplier test. But a pilot doesn't necessarily like to see a supplier test. They would probably be flying. So yes, it did involve a cultural change, and you know, I could give you a presentation of how we managed the cultural change on the organization, because it was a cultural change. It was. The easy part is the procedures, how to do it. That's a relatively easy part. The more difficult part is to get the individuals aligned and understanding the interest of that. So it's for me, my message would be, the procedures is not the issue, the SOPs is not the issue. The issue is convincing people who are not used to doing something, do something different. But in as much as we were able to offer them a more wider spread in their experience, a different positioning relative to the designers. You know, when you tell people, you know, you are the first customer, you know, that's very motivating. You will judge this product as if you're a customer. That's very motivating for people. So it's, for me, the challenge is more cultural and transformational on teams more than technical.
Do we have time for one more, Jack?
You're the boss.
Yeah, let's do one for online.
There's a really interesting question about how you think flight testing might be changed with the incorporation of novel fuels like hydrogen.
Mm-hmm.
And the question asks about what you think will be done differently.
I don't know. I don't know what will be done differently. I know the regulator is, you know, the regulation is quite robust. The regulation defines safety standards. So the regulation has demonstrated that it is able to evolve. It has demonstrated that it was able to adapt to certify airplanes that did not comply with any of the regulations. When we introduced fly-by-wire airplanes with non-moving side sticks, which did not stall, which did not have static longitudinal stability, we did not have lateral stability, yet the regulation defines the overarching safety objective, and then it is up to industry and to the authorities to say what was the objective of that, and how can we put that into words, and how can we put that into a requirement or a special condition. So I'm sure on the novel fuels and the new fuels, there will be a process like that. You know, the new fuels bring new challenges. The regulation today defines a framework. This is what is expected in terms of safety of the combustion and transportation of these fuels. And they will have to come up with new regulations. I am unable to say what those regulations are. What I remain sure is that the laws of physics will prevail. An airplane will be an airplane, and an airplane will need power plant, and it'll need to fly, and it'll need to fly well.
Okay, I'm sure there's loads and loads of burning questions, but I'm afraid we've really come to the end. So maybe to give a vote of thanks, Ian, would you mind giving us a vote of thanks? Fernando, please.
Thanks, Dougie, and thank you, Fernando, for what the word at the up there was an amazing, a really amazing lecture. It's been a real privilege to listen to. I don't know, you were concentrating on the lecture, Fernando. You probably didn't see the number of people that were logged in online. That it was about 130, 135 people all there, and it's been recorded, and this is going to go viral. I mean, a couple of observations just from me. The focus around maybe some of the softer cultural issues, I think, was a really important point. Clear vision, clear objectives. I think you used the words about, people first, putting people first. And I mean, it's great to hear all the technology stuff, but it's really good as well to hear the importance that you place on some of those softer issues. I'm sure we all felt the same emotions watching you on that first flight. I mean, that was made my heart flutter a bit as well. It was fantastic, and a really fantastic achievement. I think some of the questions, I mean, you've tackled the questions really well as well, but I think that the question that Jack raised from online about what happens next, new alternative fuels, fuel vectors. You said at the very beginning of the lecture that we are now at the cusp of a new technology revolution where things are going to be so different to what they've been in the past. So I think some of those softer cultural issues are going to be so important for us. Just to relay a funny story, when we were walking across this evening, Fernando was telling me that the story. He was across in Oxfordshire, and he went to visit Williams Engineering, one of the top tech engineering companies. And somebody put on social media that Fernando Alonso meets Frank Williams, and of course the rumor machine in Formula One went wild. But I think you would all agree with me that actually we have got in our sector the real Fernando Alonso. It was a real privilege to hear that. Dougie described some of your many achievements, but it's been a real privilege tonight to listen to your lecture. Just as a very small memento of lecture at Cranfield, Fernando, if you could accept this on our behalf.
Thank you very much indeed.
And if I could ask everybody to show your appreciation of tonight's lecture.
Thank you very much.
I get so carried away.
Thank you very much, and that concludes the lecture for this evening. Thank you.
Thank you.